Can you tell us your name and what course you teach?
Larry Bucciarelli. I'm a professor in the School of Engineering, and the course I teach in civil engineering is solid mechanics. The number is 1.050.
Can you tell us how the materials that you've made available through OpenCourseWare are actually used in the context of the class?
Well, on the site you'll find the textbook, which is not completed, probably never will be completed, Engineering Mechanics for Structures, and that's the textbook which the students purchase for the price of replication by our copy shop. But the chapters are also available on the web as PDF files.
Okay, and what do the students do with the materials in class? Do they read it as homework? Do you have them do exercises in class?
I found the textbook works very well, for me anyway, because it's, of course, I've written it, and so I don't lecture so much anymore. I ask the students and I inform the students that they're to read the textbook before class when the texts are assigned, and that way we can do more interesting things in class other than myself standing in front of a chalkboard with my back to the students, replicating what's in the text.
Can you describe a typical day or a typical lecture class meeting?
Well, I tend not to lecture. I will give some lectures, but generally I'd like to go into class and at some time in the class introduce what I call a class exercise, something that I produced, again, in PDF file, not on OpenCourseWare because these change from year to year, but it is on my Stellar site. And there's a little exercise, very much like a problem set in the problem exercise in the textbook, and there's a lot of blank space on the page. And I give these to students. I ask them to work together in teams of 2 or 3 and work out the exercise. And after maybe 10, 15 minutes of that, we will go through the exercise. I'll ask the students for their comments and critique. And of course, during the exercise, I'm going around through the classroom trying to answer their questions if they have some. And then I'll move into maybe a lecture mode for the duration of the class. But the idea is to get the students engaged.
Are the students using computers in the class, or are they doing this on paper?
They're doing this on paper. This is a first course in engineering, a required course in civil engineering. Most of the students are sophomores. For most of the students, it's their first course in engineering, though we do get some students from architecture who are in their 3rd and 4th years. So as a first course in engineering, the emphasis is on the fundamentals. Now, fundamentals in 2 senses. The fundamentals of the theory, which come over from physics and engineering mechanics. The title of the book is Engineering Mechanics for Structures. But fundamentals also in the sense of what is engineering work like? How do engineers make use of approximations, estimations, and certain models? So all of this is not the kind of online production activity of using a computer, say, for exploring options in a design setting, or though I do emphasize design context for some of my exercises in the course.
Can you say more about those exercises, or what kind of homework that the students do?
Again, there are several kinds. I've mentioned the class exercise. There's also standard home problems. Perhaps not so standard if you look at the exercises in the end of the chapters, but let's call those standard back of the chapter exercises. And they're standard in the sense that generally they have one answer. But there's another kind of exercise which I highlight, and which counts 40% of the grade in the course, and these I call design or open-ended exercises. And the students tackle these, 6 of these during the course of the semester. They're conceptual exercises. They're exercises in which there is no one solution. Some are shown in the textbook. For example, design a diving board for a world market. And there's no one answer, and so they must document their arguments and justification for their designs. And that they do in a journal. $1.50, $2 or something like that. And of course, that's a different kind of exercise for faculty too. And there, in several ways. One, it's going to take longer to evaluate the exercise, though perhaps a teaching assistant might help in that. 2, and more important, it's different in the attitude or the perspective that the faculty has to take on the exercise. It's no longer a case where there's a single answer, nor even perhaps a single method. So that means the faculty has to become a listener and not just a lecturer in class. Generally, the way I handle these design exercises is to go in with a class exercise that's related to the upcoming design exercise, have the student work through that. After all, the purpose of this is not to teach design. That's not my intent. My purpose is to teach the fundamentals of engineering mechanics, of structures, but to do it in a way where the students are engaged as they were taking on an engineering project or a design project. So this means that there's no single answer, no single method, that it's important that students participate in the formulation of the problem, in setting out constraints, in talking about the kind of resources they can make use. And here I let them use the web if they like. They can call home to find out the size of the diving board in their backyard, if they have one, as long as they report and reference their sources. I find that these design exercises work very well, and if I can say, this is the commercial part, I guess, of the broadcast, but and the students recognize that. And let me just read some comments from the evaluation, if I can, which I just received, which they say things like, Professor Bucciarelli makes this class difficult and fun at the same time. Another, I found the content very difficult, but also very challenging. I enjoyed it greatly and understood concept, but had difficulty completing exercises. I really enjoyed the class because it was taught in a way that made the material interesting to us. The design exercises were extremely hard and time-exhausting, but they were very interesting to do, and they are the reason I learned the material. Now, that in a way is the kind of response I welcome, and it's generally been the case that students do take to the design exercise, even though they are difficult. I recall one journal when I myself was up very late in the night evaluating the journals, and here was this statement, this student, after pages and pages, student had written, "It's 2 a.m. in the morning and I'm going around in circles." And I wrote back, "Great, you've discovered that design is an iterative process." Now, I could go in and lecture about design as an iterative process, but the students wouldn't understand a damn thing about what I was saying. But when they experience it themselves, that's when learning happens.
So how else would you assess them? If you said that's 40% of their grade, you either give them problem sets, quizzes?
Yeah, sure. As shown in the syllabus, which is also posted, you'll see that I think it's 40% that's on the design exercises, 30% on the quizzes, 2 quizzes, standard quizzes again, and 30% on a final exam. I do not grade the problem sets. They are evaluated. They're weekly problem sets. They're evaluated by the teaching assistant, and we tell students to come and see us if we note that they're having some problems there. But of course, not all the students tackle the problems after a while. You know, the course becomes hard enough in itself in all its other ways, and the students set their priorities and engage most of the have to engage the design exercises and quizzes, of course. And that's one of the reasons why I use these class exercises as well, because they, in a sense, are like problem set.
Do you anticipate making any changes to the class in the future, or are you be happy with the way it's going now?
I'm quite happy. I'm continually making changes in the sense of updating the textbook. There are some, I might warn any user or reader of the text that there are some places where there's some typos and things like that. Some are quite serious, and those are usually obvious, though. I don't anticipate changing the course at a great extent. I should mention there's a laboratory course that goes along with it, which is half the units of the solid mechanics course, and so it's a problem of integrating lab exercises, lab experiments with the content of the course. That's taken a while, but that seems to work quite well too.
Anything you want to say about the laboratory course before we wrap up?
Well, again, my attitude there is not to do cookbook laboratories. That is, the student goes down and turns a few dials and watches a few outputs, but to try to gauge the student with the setting up of an experiment, which is very important, and all kinds of things can go wrong with that, and I want them to experience that. I want them to have some sense of what kind of instrumentation is available, and here we consciously use some very crude forms of instrumentation in the early experiments, like dial gauges and even meter sticks. And later on, we moved to things like LVDTs for measuring displacement and strain gauges for measuring, again, strains. So there's an emphasis on the experience of setting up an experiment. There's an emphasis upon instrumentation and seeing how that can also, how powerful certain forms of instrumentation can be, but also how open to not misuse and things going wrong happens there. I don't. So again, the idea is to have the student experience the context of engineering work as much as, say, the principles or the fundamentals of the content or the focus in terms of structures and mechanics. Of course, report writing is also an element of the course. So. Okay.
Great. Well, thank you very much for sharing your materials with MIT OpenCourseware. We appreciate it. Is there any last thoughts you have on your teaching of either of these courses?
Well, no.
Okay.
That's enough.
Great. Well, thanks for your time.
Okay.